Hi everyone, it's me again. My name's Andrew. In case you forgot, maybe it's been a couple days, maybe I wasn't very memorable. Either way, today we're finally hitting the last part of our video series, and we're going to teach you today how to build an LED circuit. And when you're finished with it, it's going to look a little something like this. Now, obviously, because you guys are quarantined and we can't give you all equipment like we were planning on doing, you're going to have to do this on Tinkercad or some other platform online. But know that all of this could be done with a real circuit and a real breadboard. And when you're finished, it's going to look a little something like this, where when you turn the circuit on, you start simulating it, this LED is going to turn on right over there, that red LED right there, which is pretty cool. So that's what it's going to look like. And here's how we're going to make it. So what you're going to do is you're going to want to go to the start screen of Tinkercad. Just like here, you're going to want to click on circuits, and you're going to want to create a new circuit. And it's going to take you to a screen that looks a little something like this. And we'll name our circuit, because who knows what swanky denser is. Let's call it breadboard circuit video. That's what I'm making, a breadboard circuit video. And the first thing we're going to need is, believe it or not, a breadboard. I know that's quite a bit of a surprise. Let's just drag this guy in here. Now what we're going to need is, like we have in this, we're going to need a battery to be able to power the circuit, just like our solar cell board. We're going to need a resistor, and we're going to need an LED. And I'll tell you why we're going to need a resistor later, but we're trying to turn on a light with our solar cell or with our battery, so that's why we're going to need the LED. So what we're going to do is, the first thing we're going to do is we're going to drag our battery in. We're going to be using a 9-volt battery here because it's one of the most common batteries used. But just know that this could be easily replaced with a solar cell or anything else that produces energy. So this is just sort of more of a conceptual stand-in for what we would be using later. You could use a solar cell, or you could use any other renewable energy source. But today, just to keep things simple, because they don't have a solar panel here, we're just going to use this battery. Next, we're going to need an LED. So let's find our LED here. Up at the top of the basic components section, you're going to find LED. We're going to click on this guy, and we're going to drop him in. And the last thing we're going to need is a resistor. So we're going to click on this guy, and we're going to drop it in. Now you can actually change how or what resistance the resistor has, and we're going to talk about that a little later. About why we're going to need this resistor. So the first thing we'll do is we'll wire the 9-volt battery up. So let's take the positive end and drag it to this positive terminal right here, that column with all the green things sticking down from it. I'm going to make my wire red just so it's easier for everyone to understand, but you guys don't have to do that. And then we'll take the negative end, we'll stick it in there, and we'll make this black. So this red side, the positive end of the battery, is hooked up to all this. The negative side of the battery is hooked up to all that there. Now we're going to need to hook this battery up to the LED. So what we'll do is we'll drag the LED into the circuit here. The LED actually has two sides. This side that has the longer lead here, or the longer wire, is called an anode. This side here is called the cathode. When you wire an LED, you always want the positive wire to go in to the anode and the negative wire to come out of the cathode. So if we put the LED like this, we're going to have to wire the circuit so the positive end goes around here into the anode, up through the LED, out through the cathode, into the negative part of the circuit, and back into the battery, so it forms a closed loop and electrons can flow throughout the entire circuit with the battery powering it. Why do we need a resistor in this? Well, the real answer to that question is that if we just only have the battery powering the LED, and no resistance, because of how Ohm's law works, the current is going to be extremely high through the LED. And that's going to mean that the LED could burn out extremely quickly or could just blow up if we power it that way. And we don't want that to happen. That's really dangerous. And if anything, our LED might just break, which is a waste of our time and money. So we're going to throw a resistor in there just to balance out the circuit numbers-wise, and then to make sure that the LED actually works. So with this, we have a red LED here. How it actually works, and I think I have this on my sticky notes, and we'll have that keep on top. The current that flows through an LED, it actually has a cap on the amount of current that can go through it. Current can only go in this one direction, and it's 20 milliamps, which is the same as 0.02 amps. So that's how much current is able to flow through the LED. The LED is also going to have a voltage drop of 3 volts, which means that of these 9 volts, 3 of them are going to be used to power the LED. What that means is that 6 volts are going to have to flow through our resistor. And the reason that that's the case is because the entire battery is 9 volts. And we know that that 9 volts is going to be equal to the 3 volts that are flowing through the LED plus the question mark amount of volts that are flowing through the resistor. If we subtract 3 from both sides, that's just some algebra, we get that the question mark is going to be equal to 6 volts. So we know that the drop over the resistor is going to be 6 volts, and the drop over the LED voltage-wise is going to be 3 volts. So with all that in mind, we actually have a mathematical equation that we can use to figure out how big of a resistor we need, what the resistance is. And I'll sort of go ahead and write that down on a little whiteboard I have up here. Let's see if I can find it. I call it paintbrush. So what we have is an easy equation. We know that V equals IR, and excuse my handwriting. My laptop mouse isn't really the best at doing this. But we know that V equals IR. That's Ohm's law. We've already talked about that. We know that the voltage drop over the resistor is going to have to be 6 volts for the LED to work right. So that's going to be 6 volts equals the I through the resistor, which we know because it's in series with the LED, it's going to be the same as the current through the LED, which is going to be 0.02 amps. So we'll call it 0.02 times, which is that little dot here, the resistance. And now we have an algebraic equation where we have only one variable, and we can really easily do this math. So in order to solve resistance is just going to be V over I, which is sort of the reverse form of that equation here that you can use to solve resistance if you jiggle it around a little. And if we actually pull up our calculator, we can find, so I already have the answer there, that R is going to be 6 divided by 0.02, and that's going to be 300 ohms, not 150. I don't know why I had that up there, but 300. So our resistance today is going to be 300 ohms. So what we're going to do is we're going to change this resistance to 300 ohms. Cool, and we have it just like that. We will go ahead and remove these stickies, and just to get the resistor to work with the breadboard right, we're going to rotate it just a little bit like that by clicking this button up here, this rotate button. We're going to drag this resistor right in there, and we're going to put the positive lead right there to where the resistor is going, easy as cake. And we're going to take this end and we're going to throw it on the negative right there. And finally, we're going to start our simulation. Lo and behold, the LED is running. It lights up. We wired our circuit right. If you guys have any questions, feel free to post them in the comments. I know we'd love to give them an answer. Once again, I hope everyone's having a fantastic quarantine. Hopefully this inspires you to build some more circuits when you finally get out. Once again, my name's Andrew. Thank you so much for watching, and everyone have a fantastic summer. Thank you.